Okay, so here, right, last time what we did was we actually, solved examples, that is, we did some systems of linear equations in two unknowns, okay? And we saw different methods for solving such a system. We saw substitution, okay? We saw elimination, okay? Graphically, solving them by graphing, that is the method you can use to solve such a system. I didn't really emphasize that too much because I figured we have Desmos, and because I'm teaching this online. I mean, if it was in class, then maybe I would emphasize it more. But I just figured we have Desmos, which is a free, online graphing calculator. All right, but here we have these two examples that I want to solve using elimination. So let's solve this here using elimination, okay? All right. So remember, with elimination, what you want to do is somehow eliminate a variable, okay? That's what you want to do somehow. And you do that by manipulating the coefficients. Basically, what you want is for a certain variable, right, either x or y, what you want is the coefficients of one of those variables to be the same except opposite in sign. Like 8 and -8, or 2 and -2, for instance. And then you add the equations, which will kill off one of the variables. Okay. So for instance, here we have 8x minus 6y equals -20. Here we have -16x plus 7y is 30, right? So we have -16x here. Now 8x we have, okay. Well, if we were to multiply by 2, the first equation by 2, 8x would become 16x, right? So you would have 16x. What's the question? Okay, it's okay, no worries. So we have here so here we had 8x. Now, if we multiply by 2, this would become 16x, right? Here we have -16x. So if we were to add these, the x's would go away. So let's do that. So we're going to multiply the first equation by 2, both sides, that is. We get 16x minus 12y is -40, okay? That's what we get here. 16x minus 12y equals -40, right? And this would be our new first equation, so to say. So now if we were to add, you can see that the x is gone. The coefficient becomes 0, and so the x is gone. Okay. Here we have minus 12y plus 7y. That's just minus 5y. Here we have minus 40 plus 30. And if we add it to 30, we get minus 10. So what we end up with is the equation minus 5y equals minus 10. That's what we get here. And so we have this equation to solve. There's only one variable, so it's easy, right? You just divide by -5, we get y equals 2. That's what we get here. Y equals 2. Okay, that's awesome. Now, we're not done though, right? Because we have to figure out what x is. That's what we need to figure out as well. We have to figure out what x is, okay? Okay, how do we do that? Well, for the y, we can take that, y equals 2, we can plug that into either one of the two original equations. we can do that. Okay, so let's do that. So let's plug it into the first equation. You could have done the second. So we have 8x minus 6 times y. So minus 6 times 2 equals minus 20. 8x minus 12 then is minus 20. So what do we want to do? We want to solve for x. That's what we want to do. Okay, so how do we do that? Well, let's add 12 to both sides, right? We get 8x then is minus 8, okay? And so, of course, what do we do then? We divide both sides by 8 because we want x. We get x is minus 1. So the only solution here then is -1, 2. I mean, you could graph it in Desmos to see if we're correct, as sort of a check, so to say. Okay? All right. Any questions on this one? All right. Okay, so here is another example. So it's the same idea basically, right? We're using elimination. So what we want to do is somehow kill off a variable. There's usually more than one way to pull this off. For instance, here we have 6x, right, in the first equation. Now in the second equation, we don't have that. We have minus x. But if I multiply the second equation by 6, what will happen then is the second equation will become -6. Well, the term here, that is what I meant to say, although you can see it down here, will be minus 6x, and then you can kill them off by adding. You can kill off the x by adding, that is. Okay, so let's do that. So we're going to multiply the second equation by 6. We get -6x minus 36y equals 24. Okay. Then the system becomes this. Now you can see, oh, well, if we were to add these equations together, the x's would go away. And we would get minus 12y minus 36y. Excuse me, if we were to add them together, x is gone, right? The coefficients are the same, except they're opposite in sign. Here we have minus 12y minus 36y, which is minus 48y. 24 plus 24, right? That becomes 48. So we have this new equation here, okay? Dividing both sides by minus 48, right? What do we get? Well, we get y equals -1. Again, we got this equation here. We divide both sides by minus 48. We get y equals -1. Now, of course, we're not done, right? Because we only have y. We want x and y. But what we can do is take this y, plug it in to either one of the two original equations. Now notice the coefficient of x here in the second, -1 is a little bit easier to deal with than 6. So I'm going to plug this in to the second equation. There we go. See? But either equation you can actually plug it into. So we have minus x minus 6 times -1, which is 4. Okay? That's what we have here. So minus x minus 6 times -1 is 4. And of course, this is the same as minus x plus 6, which is 4. Right? 6, so we have that. We want to solve it for x. So we subtract 6 from both sides. And we get minus x equals -2. Okay, but we don't want minus x, we want x. So how do we get rid of the negative? We can divide both sides by -1. And that's what I'm doing here. We get x then equals 2. So the only solution here is 2, -1. And that's what we get. Okay. Are there any questions on this one? Because now we can start reviewing. Okay. Okay, so I want to start off with reviewing trigonometry. Okay. And this is just a reminder of how sine, cosine, and tangent are defined. If you have a right triangle, meaning an angle is 90 degrees, okay, the side opposite that 90-degree angle, right, that's the hypotenuse. Hype is the length of the hypotenuse. We have an angle theta, which is one of the two other angles. This side here, OPP, this is the length of the side opposite the angle theta. That's the length of the side opposite the angle theta. ADJ, that's the length of the side adjacent to theta. You know, the side opposite the angle theta, that's the opposite side. The side next to theta, the side that's adjacent to it, is the adjacent side. And then you have these three trig functions. This is how they're defined. You know, sine of theta is this, and so on. We've seen that before. SOHCAHTOA is a good way to remember it. There were those other trig functions as well, like secant, cosecant, cotangent. I mean, you could remember them using their formal definitions. I mean, I like to use what they call the reciprocal identities. We'll get to that though again. All right. So here's an example, for instance. So let's assume tangent of theta is between 2/5. Now, I didn't write this down, but we're assuming as well that theta is between 0 and 90 degrees. You know, we didn't go over how to consider, I didn't go over in this class how to find the trig functions for negative angles or angles greater than 90 degrees. So, but here we're basically assuming that theta is greater than 0 degrees and less than 90 degrees. And we know tangent of theta is 2/5. We're going to find all the other trig functions, but we're not going to figure out what theta is. Okay. Well, how do we do that? Let me just pause the recording.